Okay, today's lesson is on graphing absolute value equations. Absolute value equations, you've seen a couple of examples already. They are very similar and look similar to parabolas, so they act very similarly to parabolas as well. Remember that I'm going to put the parent equation up, which in vertex form, y equals the absolute value of x minus h plus k. And if you remember your parabolas or you know your parabolas, that looks very similar, except for the vertical lines here would be parentheses. And then we know that the vertex is h comma k as a set of points. I'm going to put a little circle around that. Here's our parent equation. And they act very similarly to parabolas. So if you are good with graphing parabolas, you should, in vertex form, you should be good with graphing absolute values in vertex form. So let's get started with our first example. And the first example says y equals the absolute value of x minus 2. Well, to find our vertex first, it is h comma k. There is no value for h, so that would be a 0. And our k value is negative 2. So our vertex is 0, negative 2. It's a y-intercept on the y-axis. Based on that, we can find our other two solutions, or our other 2 points that we're going to plug in, by being the same distance away from 0 on a number line, so positive 1 and negative 1. And then we'll put our fourth and fifth point, positive 2 and negative 2. As long as they are the same distance away from 0 on the number line, or your vertex, you'll be good to go. So now what we're going to do is we're going to figure out the y values for our x values by substituting them into the original equation. Y equals the absolute value of x, and instead of x, I'm going to put a positive 1 here, minus 2. So that would be y equals the absolute value of 1 is 1 minus 2. So y equals 1 minus 2 is negative 1. So our negative 1 goes in there, and the negative 1 also goes in there because they are the same distance away from 0. If we were to substitute a negative 1 up here, the absolute value of negative 1 is still 1. So that's what allows us to fill those in. I'm going to show you the example for the second one. Y equals the absolute value of, I'm going to select negative 2 as opposed to positive 2. The absolute value of negative 2 minus 2, just to show you the difference. So y equals, what is the absolute value of negative 2? Well, it's 2. Subtract 2, y equals 0. So 0 and 0. Now what I'm going to do is I'm going to graph those 2 points, or those 4 points. So positive 1, negative 1, negative 1, negative 1. And then I will graph positive 2, 0, and negative 2, 0. And what this turns out to be is a 2 straight lines that look like that. Kind of like a V, capital V. Sometimes it's wider, sometimes it's more narrow. Okay, and that's what an absolute value equation or an absolute value graph looks like. Let's look at the second example. A little bit different from the first, but we're still going to graph it the exact same way. Our vertex, the opposite of h, or it's just h, which is a positive 2. There is no k in this situation, so that would be 2, 0. So our vertex point here is, instead of 0, negative 2, so over here on the x-axis, it slid right as opposed to sliding down in the first example. We have a positive 2 here, so 1 unit above 2 is 3, 1 unit below 2 is 1. And then 2 units above 2 would be 4, 2 units below 2 would be 0. So now we are going to substitute our values in to find our other points on the graph. Y equals the absolute value of 3 minus 2. So y equals the absolute value of 3 minus 2 is 1. So y equals 1, because the absolute value of 1 is 1. So 1 and 1 We could plot these points if you want. 1, 2, 3 to the right, 1 up, 1 to the right, 1 up. And then our fourth and fifth point, y equals, again, I'm going to use this as an example just to show you it doesn't matter what values you pick. 0 for my x minus 2. So y equals 0 minus 2 would be a negative 2. Y equals, the absolute value of negative 2 is 2. 2 and 2. So positive 4, positive 2, 0, positive 2. And our graph looks like this. Again, these absolute value graphs look to be capital V's. Parabolas are a curve. They're a U. Absolute values are more angular. They're capital V. The last one we're going to do is this last one down here, and it looks a little bit different because we have a negative sign out in front of the absolute value. So our vertex is still the same. It's still h, which is 4, and our k, which is, again, is 0. If there were a number there, we would add it in. So 4, 0, we're going to start out here, and then we're going to create our values. So we're going to go 3 and 5. And we're going to go 6 and 2. We're going to substitute in y equals the opposite of the absolute value of, let's go 3 minus 4. So y equals the opposite of the absolute value of negative 1. Y equals the opposite of, the absolute value of negative 1 is 1. So in this case, it's going to be negative 1 and negative 1. And then our last 2 points, y equals negative, or the opposite of, 6 minus 4. Opposite of that, y equals negative 2. Plot our points. Positive 6, negative 2 right there. Positive 2, negative 2 right there. Positive 5, negative 1 right there. Positive 3, negative 1 right there. Connect your points. They are angular. What I would like you to do is I would like you to go through and finish 2, 4, 6, and then flip it over on the back, and you have 6 more absolute values to create the table and graph. Check with Mr. Jellis or check with your teacher, whoever your teacher is, to confirm that your answers are correct. Have a great day.